Hey, Lily.
Hey.
How are you? Oh, you know what? I was just emailing you.
Okay.
I was here all by myself. I said, please come visit me. That's what I was getting ready to do.
I love her.
I know, she's so sweet. It's Sarah Davis's granddaughter. Yeah,
Oh my gosh, I'm in the floor.
I know.
Oh yeah.
My family, my daughter Brooke, who doesn't know you, is already in love with you just because you're Sarah Davis's granddaughter. But what I was going to do with regard to the functions, were you talking about a few of the things on the worksheet, or were you talking about the 3.7 homework? Because the 3.7 homework, I definitely want to make sure that you get.
It was a little bit of both. On the worksheet, I didn't understand number 23.
Okay.
I don't know if you have that.
Let me, yes, I do have it, but I want to bring it up over here on one place, and then I'm going to bring it up. So we're going to do the worksheet first. Oops, wrong thing. Number 23, where the table was?
Yes.
Okay, cool.
Brussels sprout latkes. They look so good. Look how good those look. They're Brussels sprouts.
Oh, there they do. Oh, and the other thing we were talking about just before you got on is how good your mom's like baked goods are.
Oh. You're baked good.
Hey, Kelly.
It's like a video.
Hey, how are you?
Hey, how are you?
Good.
Thank you
That's
for your help.
Michelle. And Michelle is Sarah's daughter, and she's the one that does all the baked goods. I'm connecting the dots for my daughter, Brooke, who doesn't know y'all as well as Mo does.
Oh, gotcha. Okay. Well, thank you for your help. With all these graphs, I'm decent with math, but I lose it at the graph. So it's like, you're going to have to ask for help.
Oh, okay. That's fine. I'm just trying to bring up that worksheet now.
Okay.
I was trying to pull it up into a PDF because I feel like I did it earlier. And I mean, I already had it in a PDF, and that's why I was like, oh, I want to bring it up so that she can see it. Because it's easier if I work it out and fill it out for her. And then I'll share the screen with her. Oh, my dog's about to bark too, and I'm sorry.
Why?
I don't really know. Maybe it's because he's here in the laundry room. I don't know. You know, Finn, he barks at random things that we have no earthly idea. Bless his little heart, what he's doing.
The washing machine door is broken.
Why did she try to get up on top of it?
No, it's like, it's down.
Okay.
It came off the hinges.
All right. I'll have to get to it in a minute.
Yeah, you're fine. No, I tried to get on it earlier.
You have to stand on the sides.
No, I was standing on the wash. Did I not tell you? I was sitting on the washer. I fell off. And so I was trying to catch myself on that door. That's the only thing I had.
On the dryer or the
I was
washer?
standing on the washer. And I
Oh.
fell like sideways.
Oh. Okay. Ooh. Glad you weren't hurt.
Oh yeah.
Oh, here it is.
Half my toenail came off.
Oh, buddy.
But
All right, let's see. Oh, here we go. Found it. Yay. Sorry.
You're good.
balsamic reduction with bacon be good?
Okay, can you see it?
Yes, ma'am.
Okay, great.
Thank you.
Oh, no problem. On the tables for the functions, basically what you're going to do is like, can you see it pretty good? I tried to blow it up in the table.
Yes, ma'am.
Sometimes has a tendency to go away. Does that look a little bigger for you?
Yes, ma'am. Thank you.
Okay, cool. All right, the X part right here, that part is just to kind of give you an idea, that's an X coordinate, and this is the Y coordinate. So anywhere, like in this particular table, what you would do then is you would fill in this X into this particular function. So it would be f of x, because that's just a fancy labeling for a y, equals 6 plus, and then notice that's where the x is. So you would just fill in that -1 where the x is, because that's basically telling you, okay, here's your value for that. Okay. And then you would just solve. So 6 plus a -1 is what?
5.
5. So that's what would go here. So that's telling you that f of x equals 5. And basically, kind of what you would see, which this might be a piece of what's confusing you a little bit, is sometimes you'll see this x with the little -1 inside here. And that's basically saying this function at the value of -1 is what? So it's looking for the answer. This means this function at a value of -1 is 5.
Okay.
In other words, the y coordinate is then 5. So that means if you were graphing this particular ordered pair on the function, it would look like -1, 5.
Okay.
So each one of these is going to be an ordered pair. So just because this last one is a little more like the first one, I'm going to erase this, and we're going to skip over to the 0 piece. And we're going to plug that in. So this function at the value of 0, so at the function at 0 is what? What's the answer?
6.
Yep, that's it. So you would write 6 there. Okay? Now, this one is telling me that the answer is 2. So it's telling me this part is 2.
Okay.
So what it wants you to do, oops, I probably shouldn't have written that there. It wants you to figure out if the answer is 2, what is the x going to be? So it wants you to solve this equation for the answer 2. So you're going to subtract 6 from both sides, and you're going to get -4. So the x is -4. So how I would write that in syntax, f at -4 equals, the 6 plus -4, which basically turned out to be 2. Does that make sense?
Yes, ma'am.
Okay. So on this bottom one, let's do that one together too, just so you get a little more practice.
Okay.
And then we'll go to the homework. Okay. Now what we're going to do is this one says it's giving us all of the values of x, and all we have to do is find the answer, which is the f of x. And the f of x is just the answer. It's just a fancy way of saying the answer. basically what it's saying is when you plug in a 0 for x, what do you get? So if you multiply 7/2 times 0, what are you going to get?
0.
0. Good job. So now what I'm going to do is we're going to plug in 2. But when we plug in 2 this time, just to make it a little easier, I'm going to state it in a fraction because 7/2 is a fraction, and it'll just make it a little easier. Remember, we're going to simplify before we multiply. So those two would cancel out, and that's going to leave us with -7/1 or -7. So that's the answer.
Okay.
So that fills in that whole chart. So this is the value wherever the x is, and this represents the answer.
Okay.
And usually, and you'll see this when we do the homework, which, let me bring up the homework. I think it started on page 203, didn't it?
Oh, I did a different one.
The 3.7? This is yesterday's. This was yesterday's classwork. You were supposed to do that other stuff for extra practice, but I was going to go to this classwork to make sure you understood this. And then we can go to the review if you want to. Was there more questions on the review that you had?
Yes, ma'am. I don't know. Was that the classwork we did yesterday?
I'm sorry?
That was the classwork we did yesterday?
Yes, ma'am.
Okay.
Did you understand that okay?
I think so. I'm just trying to find it.
Okay, because it was evaluating functions. So when I got your email about the functions, I thought maybe perhaps that's where you were struggling. And I was going to try to I'm going to see if this works. You'll be the first person that I've been able to do this with. This is awesome.
Okay. Yeah, I see it.
Okay. When it says evaluate the function when x is this, this part is when you're actually plugging in, and I know you didn't do number 4 yesterday, so I'm actually going to work that one. Okay. What you'll do is plug in the -2 here into this x. So it would be like -3 times -2 plus 5. So that's going to be a +6 plus 5. And then that's going to be 11. So when it says evaluate the function, that's when more than likely you're going to be plugging in a value into x, this part right here, and getting an answer. And there are definitely some of these on the test tomorrow. So that when you evaluate, that means whenever you see this x, obviously you're going to plug that into x. Does that make sense?
I just get confused whether to plug it in like where it says g of x or where it says -3 of x. I get confused like where to plug it in. Okay,
and that's what I'm going to try to, now I'm going to try to, oh my, it turned out real big. Can you see it? All right, this says finding x values, and it means find the value of x when it's given a number. So what that means, so this time, so if you can think of evaluate, it means you're going to plug something into the x. when it says find the x values, then it means you're going to plug it into the answer. Does you see the difference? So 3 equals 6x plus 9. So this time on these problems, so if you're finding the x value, then you'll plug in the answer. But if it says evaluate when x equals something, then you'll plug it into the x.
Okay.
So here, then to evaluate, you would subtract 9 from both sides. That's going to give you a -6 equals 6x. And so then you would divide both sides by 6. And so my answer, I'm going to write up here where you can see it a little better, is going to be -1 equals x.
Okay.
So that's kind of the difference. I'm sorry?
Which one were you on? I couldn't find it on the...
That was number 14 on yesterday's classwork. I did one that you didn't do.
Okay.
But it was in that same section here. You know, on this section, it was page 204. You all did 15, 17, 19, and 21. I think. Does that make sense?
Yes, ma'am.
Okay. And then I'm going to go to this chapter summary because you did problems back here.
The chapter review?
Yes, ma'am.
Yes, ma'am, I did.
Okay. Now, which ones were you okay on this part? Can you see it on my screen?
Yes, that part was,
okay.
Yes, I was okay with that part.
You're okay with that part?
Mine was on, I think it was 3.5.
Oh, 3.5. Okay, because I was going to say you were supposed to skip 3.6, so I wanted to make sure you did do that. Graph using slope-intercept form?
Yes, ma'am.
Okay. Well, there's definitely some of these on there. Let me see if I can capture a region here. Now. My internet is so slow. Hoping it'll pop up soon. There we go. Okay. This, oh, you know what? I'm not going to be able to draw on here, I don't think. 4x minus y equals 3. Oh, that's scary. Okay. I think one of the first ones, correct me if I'm wrong, was 4x minus y equals 3. Is that correct?
Yes, ma'am.
Okay. So I want to get it in slope-intercept form, which is y equals mx plus b. So that means I'm trying to get the y all by itself. So what I'm going to do is I have to subtract 4x from both sides. And so then that's going to leave me minus y equals negative 4x plus 3. Okay?
Okay.
But I can't have a negative y, so I'm going to have to divide both sides by a negative 1. Which then that's going to give me y equals 4x minus 3. Do you see where I got all of that?
Yes, I just flipped it around. Like, I didn't do all this solving. Like, I just put the y in front, and I got the same answer.
Oh, you did?
Uh-huh.
But you got 4x minus 3? Okay. Well, I wish I could see how you did it. Explain exactly what you did.
Well, it says 4x minus y equals 3. So I just put y in front of the 4x, and then I just had y equals 4x minus 3.
So you had y minus 4x
No,
equals.
I just had y equals 4x minus 3. I don't know. I just changed things around.
Okay. Well, you would have to be cautious when you do something like that, only because you have to make sure your signs, because whenever you move something to the other side of the equation, it changes its sign. So just make sure that, when you're moving things around that, you're taking your signs with it. But you knew to get it in y equals mx plus b format, right?
Yes.
Which is great. That's awesome that you knew that. So you knew to do that in the first place?
Yes, ma'am.
Oh, awesome. Awesome. That's so wonderful. Okay. Well, now, what is the m once it's in this y equals mx plus b? What is the m?
4.
Right. And what does the m stand for? Do you know?
The x-intercept?
It stands for the slope.
Yes.
Okay. So the slope is rise over run. And 4, so that you'll have two numbers, 4 written in a fractional form is 4 over 1, right? Okay, so the slope, m, or the slope, is 4 over 1. And do you know what this is right here, this negative 3?
The y-intercept?
Yes, ma'am. It is the y-intercept. So that means where it crosses the y-axis, and that's going to be at negative 3. So what we'll do is we'll count down 3, 1, 2, 3, like this, and you write your dot right there, okay? And now we'll use the slope to graph the rest of the line. And by that, I mean slope is going to be rise over run. So I'm going to go 1, 2, 3, 4 up and 1 to the right. I'm going to go in 2 positive directions.
Okay.
Okay. And then I'm going to go 1, 2, 3, 4, and then 1 to the left, because both of those are both negative directions, and 2 negatives make a positive and 2 positives make a positive. So, and then 1, 2, 3, 4, and 1 to the right. That gives me a total of 4 lines, which is more than enough to draw a line. And then I connect the dots. And my lines are not very pretty on this, but that's it.
Okay. I'm still a little confused on how you did the 4 over 1 for slope.
Okay. Okay. All right. Thank you. Let's go back and review that. Great question. Okay. we got that the slope is this m part, right? That's the slope. And we know it's the coefficient on the x. That part we're good on, right? That part you understand? Right?
Yeah.
Okay. Well, we know that slope is rise over run.
Mm-hmm.
So because of that, even when we have a whole number, we want to make it something that is fractional so that we have a direction that we can count. Does that make sense?
Yes, ma'am.
Okay. So if I ask you to change the number 4 into a fraction, what would you tell me?
I think I just got it. Like I was trying to figure it out. I think I just got it.
Okay.
You go up 4 from the -3 and then over 1.
Yes, because 4 over 1 is the same thing as 4.
Okay.
Right?
Yes, ma'am.
And just so that I have a number to count, I'm looking for to have something as my run.
Mm-hmm.
So that's why I always tell you guys, fractions aren't going to be so bad once you learn slope, because you're thinking rise over run and you like to have two numbers to count, when you're doing that. So the first thing you do is plot that y-intercept. And then the second thing you do is count your steps. But would you mind reading me the next problem, and we can work that one together too?
Number 19.
And that's in the review, in the chapter review at the end of the chapter. Is that correct?
Yes, ma'am. The 3
Yeah. Would you mind reading that to me, please?
3
Okay.
minus 6y equals 9.
Could you say that again? I'm sorry.
3x minus 6y equals 9.
Did I write it right? Can you see it?
Yes, ma'am.
Okay. So what I'm going to do is subtract 3x from both sides. So then I get 6y equals minus 3, x plus 9. And now I'm going to divide both sides by -6 because I want to get y all by itself. And that's going to give me y equals, and then -3 divided by -6 is going to be a positive 1/2. Good job, Lily. Good job. And then 9 divided by -6 is basically going to reduce to -3/2, right? Yeah. That's going to be an interesting one to graph. I'm going to write this here. Y equals 1/2 x minus 3/2. Okay. So my y-intercept is -3/2. That's going to be fun. So that's like -1.5. So I'm going to go down 1 and then 1/2. That's roughly 1/2. Okay. And now my rise over run, or my slope, is 1/2.
Okay.
So I will go up 1 over 2. Up 1 over 2. Or down 1, left 2. Down 1, left 2.
Okay.
So I had another student asking me, like, when you take this, could you turn that into a decimal? If it's easier for you to graph that as a decimal, you could, but That's just, you know, it's strictly up to you, but it's really good to leave your slope in fractional form because that's where you're doing all of your counting.
Okay.
Do you want me to do one more, or do you feel pretty good about it?
Sure. That would be great. Thank you.
Oh, I don't mind. I'm gonna erase all of this. I know. She's so, yeah. No, she works so hard. My daughter Brooke's really proud of you for being honest. Brooke was exactly like you in school. She had to work very, very hard, just like you do.
Kelly, we owe you lots of peanut butter balls.
Praise the Lord.
Thank you so much. You're so sweet.
Oh no, I'm happy to do it. I'm just glad when students want me to do this and show up. I mean, I completely understand.
That's great.
Okay, what was the last one?
Number 20, it's negative 3x plus 4y minus 12 equals 0.
Okay. All right. So there's lots of stuff going on here around the y. So I think the first thing I'm going to do is go ahead and add 12 to both sides. And then I've got negative 3x plus 4y equals 12. And then I'm going to add 3x to both sides.
Oh, wait, yeah, that's right.
Did I do it right? Are we doing the right one?
Variables, that's why. I just got confused.
Okay. And now we're going to divide both sides by 4. So that's going to give us a really cool slope of 3/4 x. And then 12 divided by 4, that's nice and pretty. That's 3. So this is my crazy y. So what's our slope on this one?
3/4 x.
Yes, 3/4. So m equals 3/4. 4 is a little sketchy. And then this is our y-intercept. 3 is. I don't think so. All right. So my y-intercept is 3. So I'm going to go 1, 2, 3. And it's right there. And now my rise overrun is 3/4. So then I'll go up 3, 1, 2, 3, and to the right 4. I'm moving in positive directions. Sorry about those 2 extra dots there. I'm moving in positive directions because this has been positive. Have we had a negative slope yet?
Maybe. I don't know.
1, 2, 3, 4. If you had a negative slope, one of your directions would have to be positive, would have to be negative, and one would have to be positive.
Okay.
That's the big difference with a negative slope. But that's this one. Do you feel like you could do it on your own now? Like, do you want to show me that you can do it tomorrow on your own before we do the test? Just so you can feel good about it?
Sure.
Okay.
Okay, sorry if I'm not so attentive. Let me do it.
Were there other questions that you had on the review?
I'm looking through it. I was confused on some of the story problems, but
There's only one story problem, I think, on the test, and it's very much like numbers 11 through 14 on the front page of the review.
Uh-huh.
So if if we can pull that up again if you want to and go over that. Oh, whoops. Where was, let's see. Okay, here. It was exercises 11 through 16.
Okay.
And what you're going to do on it, it's almost the same exact thing. It says the graph shows the distance of a car traveling along a straight road for 8 hours. A positive velocity is a motion to the right, and a negative velocity is a motion to the left. It's very similar to that wording. And then the question is very similar to this one where it says determine the rates of change in distance with respect to time. So this is your time along the x-axis, and your distance is this y. It's along the y-axis. So if you look at this, from 0 to 60 miles, that was done in 2 hours time. So you would basically take 60. Remember your rise over your run. So that's your rise. The mileage is your rise, and your run is the hours in this particular case. And it was 60 miles in 2 hours, which technically reduces to 30 miles per hour.
Okay.
Okay, so you're going to do basically the very same thing. Over here, you went from 120 back down to 0. So that represents a negative distance, but we're going to talk about that in respect to velocity here in just a minute. So that was 120 miles, but it was 4 hours of time. So then that reduces to negative 30 miles per hour. And what that means, what velocity is speed. We actually talked about this, believe it or not, way back in 7th grade math when you and I began our careers together. We talked about speed and velocity. And back then we talked about things going up and down, but speed was always positive, but velocity could be positive or negative depending upon the direction. And we, like I said, back then, if it was going up, the velocity was positive, but if it was going down, the velocity was negative. In this case, the positive velocity is a motion to the right, and the negative velocity is a motion to the left. So basically it says what times were the car traveling to the left. It would have been from hours 4 to 8.
Okay.
And what times were the car traveling to the right? It would have been from 0 to 2 and 2 to 4. And then, I'm sorry, go ahead.
How would that be traveling to the left? Is it just like straight up?
Okay. Over here, when it's traveling to the left, then when it's a negative velocity in the directions, it says a negative velocity is a motion to the left. So it's telling you that. So that means when you went from 120, see how it goes from 120 back down to 0? That you're going from 120 to 0. So that's negative. Does that make sense? Because you're going down. You're going it backward.
That makes sense.
So, because you're at 120 and you're going kind of back to the 0. So that's what makes it negative, 120 over 4. So it's telling me if I get a negative velocity in my answer, which I did when I figured the 120 to 8, then it's telling me that the motion would have been to the left based upon my answer, because that's a negative 30. Does that make sense now?
Not really, because if looks like it's going to the right.
It does appear that way on the graph. You're right, because it's still moving to the right. But what it means, is here, let me erase some of this stuff down here. So all of that is out of there, and it'll make sense when it does appear like it's going to the right. And I completely understand where you're coming from, because the appearance of the graph and what the answer that they're looking for is it's a little different. But the negative, do you see this part of the sentence? I wonder if this will help. A positive velocity is a motion to the right, and a negative velocity is a motion to the left. So that means when I get an answer, here I'm determining the rates of change with respect to time. So when I'm getting my answers to the distances traveled in respect to time, when I'm getting those answers, if the answer is positive, then it's a motion to the right. But if the answer is negative, it's a motion to the left. So I'm not really necessarily looking at the graph at that point. I'm looking at the values that I've pulled from the graph to get the answer. Does that make sense? A little bit?
Like a little bit, but
okay. Let me, I can't get this to go back in. There we go. Okay. So from here to here, it was 60 over 2 hours. So that's a positive 60 over a positive 2. So that gives me 30. That's positive. And from here to here, I went from 60 to 120, or I went from 120 to 60, basically. So I'm still going up. So I went 60 over what, 1 hour? Because it was from 2 to 3, right?
Yes.
Because from here to here, so that was 60 miles an hour. So that's positive also. So I've got 30, and that's positive per hour. And then I've got 60 per hour. And then from here to here, I didn't move at all. I just went from 120 to 120 in 1 hour. So that turned out to be 0 miles per hour. And so far, these are either positive or negative. Well, from here, I went from 120 to 0. In 4 hours. So that's going to be a negative 120 over 4, which reduces to negative 30. And back over here, it said if you get a negative velocity, what motion am I making?
Like a left?
A left motion if the velocity is negative. So that's where that comes from.
Okay.
It's in the value, not necessarily in what the graph looks like, because you're absolutely right. Everything is going to the right, but it's in the value, in the answer that you get, because you would agree with me that going from 120 to 0 is a negative direction. Like you're moving this way on the number line. If I'm at 120 and I'm going back to 0, I'm going to the left. Right? Value wise, but not necessarily on the graph, because my time has still increased. It's just my distance in miles has decreased.
Okay.
So technically my X stayed positive, but my y changed to negative.
Okay.
But I don't know, I can't remember on the test if it's like that or not. I think it just asks for rates of change. So you would have to know, like, from here to here, that's 2 hours and I went to 60 miles. And then from here to here, I went another 60 miles in an hour. And so based on all of this, where did the car travel the fastest? In between what hours?
4 and 8.
Between here?
Yeah, like where it starts to go down.
Oh, okay. Well, if you weren't looking at the graph and you just based it on these answers, what would you say?
Oh, 60 miles per hour?
Right. That's absolutely correct. So what you want to do is get your values off of the graph and then answer your questions based on your values.
Okay.
Does that make sense?
Yes, ma'am.
Okay. So it was 60 miles an hour. And where did we travel 60 miles an hour? Between 2 and 3. So what 2 times is the car traveling the faster? Between the fastest, and that would be between 2 and 3.
Okay.
And what 2 times is the car traveling to the right? And that would be between 4, oh wait, to the left, I mean, and that would be between 4 and 8. And these, as difficult as these are, and I know that they are, I'm trying to incorporate a few more of them because a lot of the ACT math questions and science questions have types of things like this in them. So I figure if we can at least work them out together in class, it will give you greater exposure. Those types of things. I know they're not a lot of fun, but it's better to practice now, you know, and get some exposure to that before you take those wonderful tests. Were there other questions that you had?
No, ma'am.
Are you sure? I don't mind.
Yes, ma'am, I'm sure.
Okay. Do make sure that you look back over 3.7. Like I say, there's 2 of those questions that we just did. How did you do on these, finding the x-intercept and the y-intercept?
Okay.
On those, right here.
Oh, wait, that's the front page. Yes, that one was the one where you multiply each one times 0 to get the answer.
Yes, ma'am.
Okay.
And would you be able to graph those, an x-intercept and a y-intercept?
Yes.
Okay, great. And would you be able to, after you graphed both the x and y-intercept, say from this equation, would you then, if I said, okay, draw that line, basically you understand to connect those 2 dots, right? The x-intercept and the y-intercept? Great, perfect. I'm just trying to think of any other. Make sure that you can do, you know how I kind of brought up 3.7 and brought up the differences between evaluate and finding the x values. Even if you go over a few of those with your mom tonight, make sure you know how to do those. There's 4 of those on the test tomorrow. 2 where you evaluate, where you're plugging the x value in, and 2 where you're actually finding the x value based on the answer.
Okay.
Okay, so make sure you know how to do those. And I'm just trying to think. For the most part, this review was much harder than the test. So if you made it through it, you should be great on the test.
Okay.
All right.
Thank you.
No problem. Thank you for coming. I really appreciate not coming to Math Lab and being by myself.
Well, I appreciated your help.
No problem. You guys have a wonderful night.
You too. Bye.
I love y'all.
Love you too.
Bye-bye.